So we're going to solve the problem subarray products less than k. So let's first read the question. Given an array of integers nums and an integer k, return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. Okay, so let's see what this question requires from us. And to do that, let's take this example, this first test case, and see what they want from us. So we have an array 10, 5, 2, 6, and k equals 200. So the array is 10, 5, 2, 6, and we have k to be equal to 100. Now, so first of all, we want to return the number of contiguous subarrays where the product of all the elements in the subarray is less than k. So first of all, we will have to find a subarray whose product is strictly less than k, not equal to k, not greater than k, less than k. Okay, so first of all, we have to find our constraint metric. Now, what is a constraint metric? A constraint metric is what the question actually wants from us. So the question wants us to find the number of subarrays. So we want to find the number of subarrays. So the number of subarrays. Okay, let me make this b. So we want to find the number of subarrays. So that, what is the limit, or the limit on the constraint metric? So this is what we want, but this thing has to have a limit. Our constraint metric, we have to have a limit for it, and it should be less than k. So while the subarray that we are looking for, while it is less than k, that means it is valid. So we'll do something like this. So this is valid. This is a valid subarray. Okay. Now, when let me go for this. When the number of subarrays is greater than or equal to k, then it will be invalid. So it will be invalid. Let's see if we can get it right. Then it will be invalid. All right. So I think that's a very good definition. We want to find the number of subarrays that are less than k, but so this is when they will be valid, this is when they will be invalid. So let's start. Now, when you start with 10, 10 will be a valid subarray, right? It will be a valid subarray, and you only have one subarray here. So this will be 10. If we add 5, it will be 50. So we have 10 times 5, it will be 50. This is also a valid subarray. But the first subarray, this is one subarray. This subarray has a length. This subarray has a length of 1, or this subarray has a length of 1, and its subarray is just only one element. When we add this, now when we add this, the product in total is 50, right? But we can also take 10. Okay, so let me explain it like this. This subarray is 10, 5. The second subarray is 10, 5. But for that subarray, the length is 2, right? So we have 10 and 5. Its multiplication is going to give us less than k. If we only take 5 as well, it's also going to give us less than k. So 50 is less than k, 5 is also less than k. So this is another subarray, and the length of this subarray, this is valid, it's less than 100. So the length of this is 2. Now, when we continue, when we add this subarray, now this is 10 times 5 times 2, this becomes 100. Now this is invalid. This subarray becomes invalid. This entire subarray becomes invalid. Why? Because it is equal to 100. It is not less than 100. So what do we do? What do we do? First of all, we have to look, okay, since it is invalid, we have to make it valid. We have to remove this 10. When we remove this 10, we are left with 5 and 2, which is 10. So now this is a valid subarray. So how many subarrays will this particular subarray have? So 5 and 2, we have 5, we have 2. We can form one subarray with 5 and 2, and we can also form only one subarray with 2. So there are 2 subarrays. So we are going to get 2 subarrays within this. And we continue. So when we do this, this becomes valid, and we continue. So we add the 6 this time. We add the 6. Now when we add the 6, this time we are going to get 5 times 2 times 6, which is equal to 60. So 60, when we look at 60, this is another subarray. 5, 2, 6. How many subarrays can we form from this subarray? We can only take 5. Sorry, we can only take 5, 2, 6. This is one valid subarray. We can also take 5. We can also take 2 and 6. That's another valid subarray. And we can also take only 6. So within the subarray, we can form 3 subarrays. The number of subarrays in this particular valid subarray, that makes in this particular valid subarray, we can get 3 further subarrays from it. So what we do is we write this as well. We have 3 subarrays from this. So after this, we add all of this. 1 plus 2 is going to give us 3. Then we add the 2 is going to give us 5. Sorry, we get 1 plus 2 plus 2, which is going to give us 5. We add this 3 is going to give us 8. Okay, so we look at that. Now that is how we do that. So we have to write the code for this. So first of all, we have to find when the subarray that we are looking, the particular subarray we are looking at is valid. So it is only valid when it is less than k. So we can start by having a pointer point at the start. So the pointer will point to the first indices, and we can also have the answer to be equal to 0, because at this point we've not started, we don't have any subarray. Now we have to track the product of the subarray. So we have to use a variable k to track the product. We have to make k be equal to 1. So k will be equal to 1, so that we can, if you use k equals 0, we cannot track the multiplication. Because k1 is identity for multiplication, we can set k to be equal to 1. So for right in range len of nums, so right is the bound of the window that makes it valid. So when we start from right, so right is going to start here and left is also going to start here. When we are here, what we do is we say, okay, k multiply k by the first element. So 1 times 10 is going to give us 10. So times nums of right, we multiply. When we multiply, we have to check, is this valid before counting it? So we know that 10 is valid, right? But we have to check, is it valid? What if it is invalid? In this case, it is valid, so we can just increment it and say, okay, answer plus equals right minus left plus 1. Why do you do right minus left plus 1? Right is 0, left is also 0. So right minus left is 0. We have to add 1 so that we know that this is the length of that particular subarray. This is when it is valid. But if it is invalid, we have to make it valid. So while it is invalid, if let's say we have a subarray that is invalid, while it is invalid, what makes it invalid? Now we know that we want it to be strictly less than k. So if it is equal to k or greater than k, it becomes invalid. So we say while the k that we have is greater than or equal to k, that means it is invalid. What do we have to do? We have to increment the left by 1. So we have to say, okay, we have to increment the left by 1. Sorry, before incrementing the left by 1, we have to divide. So we say, okay, k, then we divide by the nums of left. So because let's say you have 10 times 5 times 2, this is 100, this is invalid. So you have 10 times 5 times 2, it is invalid. What you want to do is you want to divide the 100 by 10 so that you only be left with 10. That makes this subarray valid, right? So after that, you increment left by 1 so that it will be here. It will only cover the window or the bound that is valid. So you do this. Now one you will think that when I was solving this question, I was thinking that, okay, what if left is 0? So within the constraints of the question, we are given that the numbers in the array are 1 or less than or equal to 1000. It's between 1 and 1000. It cannot be 0. So that means we don't have to look for an edge case where the number is 0. Also, we are being told that the number is between 1 and 1000, and that will really come in handy. So once we finish this, we can just return answer. So when we can just return answer. When we return answer, we are going to get the answer. But there is one edge case that we have to think about. What is that one edge case? What if we are giving the product to be 0? Now, within the question, we are told that the numbers will be between 1 and 1000. It can never be 0. So if k, the product that we are going to be given to the value that we are going to be, if k is less than 0, then we can just return 0. There's no possible way to get a subarray that will multiply to 0 because the numbers themselves we never get 0. Another way to think about it is, okay, we want the numbers to be, we don't want to include k. So when we are multiplying here, anytime we get 100, it makes it invalid. So we basically want numbers that are less than k. So if you get any number that includes k, then it makes all these things invalid. So when k is equal to 1, so when k is less than 0, we cannot multiply any number to get 0. When k is also equal to 1, so when k is equal to 1, let's say we make k equals 1. Let's come here. We make k equals 1. And we have, let's say, the same numbers, or we have even 1, 1, 2, 3. Now, when we multiply this by 1, this is invalid. It will make this is invalid because we said that the condition for this to be valid is it has to be less than k. But when we have even 1, the lowest number we can get is 1. When we have 1 will still be invalid, right? 1 will always be invalid. Why? Because 1 is equal to k, and we said that when something is greater than or equal to k, it is invalid. So this is this will also be invalid, this will also be invalid, this will also be invalid. So anything that is 1 or less, if k is 1 or less, then k is going to be invalid, and we are going to literally we can't get a subarray that will result in that product. So if k is less than or equal to 1, we just return 0. There's no subarray that will give us the product less than k, or even that it can give us a product equal to k, but that is not what we want. It will not give us a product less than k. So when we write this, we run it, it is accepted. So let's try to submit this. All right, so it runs pretty well, and when you look at this, we will just go through the array only once. So 10, 5, 2, 6. So the time complexity is just O of 1, and we don't use any other data structure. So the space complexity is also 1, and that is the solution for this problem.